This is part 1 of lesson 4 of unit 8, area between two curves. In this lesson, we're going to discuss how to find the area between two curves expressed as a function of x. We're also going to explore finding the area between two curves when it's easier to find them when they're as functions of y instead of x. Now, I know in the beginning it says here that we're going to talk about three-dimensional volumes, but we're going to do that in the next section. It's not in this section. So we are going to look at two different cases with area between two curves. As I said, one is our typical case where we have a function that is a function of f and x, I'm sorry. So we have like our parabola here, and then we have some other curve. So we're looking for this shaded area here. The other one where, while we can write both of these functions as functions of f, we're going to see in one of our examples that viewing them as functions of y is much easier. So if we can take the first function, x being f of y, the one that I drew, and then the second function, x being g of y, which is the curvy one, you're going to see that the integration becomes much easier when you do it in that way, but you'll get the same answer. Okay, so going through the first example, we're going to first graph our parabola. So what we have is a parabola that has a vertex at 2, 6, and it is vertically compressed by a factor of 1/2, and it's been reflected. So it's going to look like this. So just try to sketch this here. The next point will be here and here, like that. All right, let's see. Okay, that's not too bad. There's my parabola. That's my f of x. And now I'm asked to find the value from 0 to 5 of f of x. So that's what I'll do next. So let me just zoom out here just a little so we can see the graph and work at the same time. So part B, I'm going to find the integral from 0 to 5 of negative 1/2 times x minus 2 squared plus 6 dx. Okay, when I integrate that, I am going to get negative 1/6, because I'll raise that power to 3, and that means I'll have to divide by 3, so I get the negative 1/6, x minus 2 to the third power plus 6x, and I'm evaluating that between 0 and 5. So continuing that, I'm going to get negative 1/6 times, substituting 5 in there, I get 3 cubed plus 6 times 5, and then minus, when I substitute 0 in, I'm going to have negative 1/6 times, putting 0 in, negative 2 cubed, and then when I put 0 in the 6x, I get 0. So simplifying this, I get negative 27 over 6 plus 30 plus the second term ends up being 8/6, and simplifying that, I get 145 over 6. Okay. So next, part C says shade the region blue, so the part that I just integrated. So it was from 0 to 5. So it's going to be this part of the graph here, right there. So there's the area that I just found, right there. Okay, and then part D says graph the line g of x equal to 4 minus 1/2 x. Okay, so we have a y-intercept at 4, and then we have a slope of negative 1/2. This is when I really wish I had my ruler tool. Okay, let's see. There we go. Not too bad. And now it says find the integral from 0 to 5 of g of x dx. So I'll do that right here so we can still see the graph. So E is going to be the integral from 0 to 5 of 4 minus 1/2 x dx. So we're going to get 4x minus 1/4 x squared evaluated between 0 and 5. So that's going to give me 20 minus 25/4. And then if we put 0 in, we'll just get 0. So we get 55/4. Now, part F says shade the region green. So that is going to be right here underneath the line, but bordered by the x-axis. So then G says, how would you find the area of the region that lies between the two graphs? So that's going to be what's left of the blue area. And how you do that is you would subtract the areas. So you take the area of the biggest thing you have, which would be f of x, and subtract from that the area of the lower part, which is the green part. So that's going to be our answer for part G. So part G is going to say that we would subtract the areas. So we would do our entire area that was blue, which is 145/6, subtracting our green area, which would just leave the blue area that we have, which is 125/12. Okay, that would leave us with just the blue area that's showing. All right, so on the next page, we're going to formalize that whole idea. So the general approach for finding the area between two curves is you take the integral over the region that you want. So in our case, it's from 0 to 5. And you take the curve that is above, so that would have the larger area, so f of x minus g of x. So in our case, if we were to start this from scratch, we would have, if we're doing this just algebraically, we would have the integral from 0 to 5 of f of x, which is negative 1/2 times x minus 2 squared plus 6. And from that, we're going to subtract our line, which is 4 minus 1/2 x, and this whole thing is with respect to x. Okay, so the best thing to do is just to simplify everything to make the integral easier. So I am going to expand my parabola and put it in standard form. So when I do that, I'm going to have negative 1/2 x squared plus 2x minus 2, and then I have my plus 6 there, and then distributing the negative sign, I'll have minus 4 plus 1/2 x dx. And now simplifying 0 to 5, I just have that one negative 1/2 x squared. And then I have a 2x and a 1/2 x, so I have 4 halves plus 1/2, so that's 5 halves x. And then I have minus 6 plus 6, so all my constants go, so that's my whole polynomial. So when I do that, I get negative 1/6 x to the third plus 5/4 x squared, and I'm evaluating that between 0 and 5. So hopefully we are going to get 125/2. That's the goal here. So let's substitute and find out. So we're going to have negative 1/6 times 125 plus 5/4 times 25 So that's going to give us negative 125 over 6 plus 125 over 4. Finding a common denominator, we get negative 250 over 12 plus 375 over 12, which gives us 125 over 12, which is the same answer. Okay? All right, so now, what if they're in terms of y instead? So we're going to talk about making what's called horizontal rectangles. So we would make, if we were going to do the area, we would make our rectangles in this fashion. Like here would be a rectangle like that, okay, to the y-axis like that. If we're going to do just the part of the hyperbola there, okay? But when we do that, when we do it with respect to x, what we're going to have is we're going to have two areas, because in one section, the curve is on top. So we have this area minus the lower area. And then on the other side, the line's on top. So you'd have to integrate both areas just to get this part. Okay, it's a little tricky when you do it with respect to x if you talk about going across like this in that direction. So to make it a little easier, you can let the functions in terms of y and do it that way. So in that case, we only need to see where the two curves intersect, and they intersect here at y equals negative 2, and they intersect here at y equals 1. And in that case, the linear equation is always above the curve, and we have no need to do two separate integrals. Okay, so we're going to do our area is going to equal the area from negative 2 to 1 of, now write this out formally, f of y minus g of y dy. Okay, to label this correctly, this is going to be our f of y, and our line is our g of y. Now the reason, this may seem counterintuitive, the reason why the f is first is we're not going like we normally do from bottom to top in that respect. We're really looking this direction along this way. So if you think in terms of that way, think sideways, the f function shows more area than the g function because it's further to the right. So remember, your y value, so to speak, your dependent value is actually your x value. So the curve is going to cover an area further out on the x-axis than the line does. So that's why that comes first. Don't think up and down, think left to right. And so the larger function will be, or the one that is quote unquote above, will be to the right. So that's why it's f of y first. Okay, so then substituting, we get the integral from negative 2 to 1 of 3 minus y squared minus y plus 1 dy. So this is going to equal the integral from negative 2 to 1. Simplifying everything, we get 2 minus y squared minus y dy. Okay? Now actually taking the integral, we're going to get 2y minus 1/3 y to the third minus 1/2 y squared, and this is between negative 2 and 1. So substituting, we're going to get 2 minus 1/3 minus 1/2, and then minus, we're going to get negative 4 minus 8/3 minus 2. And simplifying all this, we get 9 over 2, if you put that all together. Okay, this is going to be really long for one video, so I'm going to split it up into 2. And we're going to look in the second video at where we have multiple points of intersection and how you can work with some trig functions and then doing area as an accumulation again. So we'll do those in the second video.